Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to set up and use a Cadence Fidelity feature in just a few minutes. Today, we are going to show you how to monitor a PBS simulation run for external aerodynamics, plot forces and aero coefficients through the command terminal using the simple driver model. In this simulation, apart from monitoring the convergence parameters, we also are plotting the forces on the driver vehicle and the aero coefficients, as you can see from the input file. As you can see, I have the driver model running now in the Fidelity PBS solver with external aerodynamics solver profile. The simulation directory is my running directory. It contains the input file, the mesh file, the run directory that contains all the simulation output, the log file. Now, you can either plot the simulation monitors from your current directory by specifying the path of the running directory, or go to the simulation running directory and then plot the monitor points. Here, I am already in the running directory called as simulation. Let me go ahead and plot the residuals first. The command is cnx plot residuals minus stream will ensure that you plot the residuals data continuously from the running simulation. As you can see, we have been able to plot the x velocity, y velocity and z velocity residuals along with the pressure residuals and that of the eddy frequency and kinetic energy residuals. And you can also see that the graph gets updated in real time. Now, within this window, you can also modify the title of the chart, the x and y axis titles of the chart by going to this specific point. I give it as aero residuals driver, and I also increase the maximum of the y axis to 0, min of x axis to 0. You can also save the current image in its current form using the save option. Now, similarly, you can plot the aero coefficients of the driver vehicle using the cnx plot forces command and using the stream command to continuously update the graphs. You can see the drag coefficient in the lower graph and the lift coefficient in the upper graph. Since I'm running an 8 million cell model, you can see the variance in the drag and lift coefficients here. You can perform similar chart modifications to these graphs as you do to the residual function. So here you can see you can make the same changes as you make to the residuals chart. Now, what do you do if you want to plot a specific force component that you have already entered into the input file? So you'll have to point your plot to the specific force output file. The force output file contains the various force components in various columns. The first column is the iteration, the second column is the time step, the third column is the CPU, and the fourth column is the total force in the x direction, the fifth and sixth in the y and z direction, and then the pressure, and then the viscous and inertial forces separately. So, let's say I want to plot the drag force, which is the total force in the x direction, which would be in the fourth column. For the forces monitoring, you have to point to the specific output file where the forces are being recorded. I use the cnx plot data command followed by the file that I am trying to plot, which is located in the run directory in the post process subdirectory under the name forces _0 hyphen forces dot out output file, and I need to point to the fourth column which is the drag forces. So y calls 4 and then I need to stream it. And you are able to see the drag forces being plotted in real time. Now you can change the name as drag forces and the X label to time steps and the Y label to forces Newton. Say apply. You got your drag forces. You can save this. You can also perform all these operations within the terminal using the CNX plot residuals or CNX plot forces or CNX plot data command and the associated parameter commands also, which are described well in the solver description documentation. If you like this video, be sure to click the thumbs up button or subscribe to our channel for more videos like this. If you have any questions, comments or suggestions, drop us a line below or connect with us via LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.